Okay, we say that when the elevator is descending with uniform acceleration A, the body inside it experiences more lighter than its real weight. And its apparent weight is given by mg minus a when the elevator is moving down with the uniform acceleration a. Okay, again let us consider the case if an elevator is moving with constant velocity, either moving upward or moving downward with constant velocity. Now, what will be the expression for apparent weight? Or what will be the weight of the body inside an elevator moving with the constant velocity? Case 3. When an elevator ascending or descending with constant velocity V. When an elevator ascending or descending with the constant velocity V. Okay. When an elevator is descending with the constant velocity v or ascending with the constant velocity v, is descending, ascending. Okay. The fact here is that when a body is moving with the constant velocity, means there is no change in velocity. And if there is no change in velocity, the acceleration of such a body is 0. Now, if V is constant, then acceleration A is equal to 0. Means change in velocity is 0. Okay, from Newton's second law of motion, from Newton's second law of motion, we say the net force acting on a body is equal to mass times acceleration A. Now, if we consider any case, either for ascending or descending, the expression will be the same. If considering R minus mg, then equals to mass times acceleration. This is for ascending, when the elevator is ascending. Now, because acceleration is equal to 0, this means R minus mg equals to 0, and therefore apparent weight R equals to real weight mg. Now we conclude by saying that when an elevator is either ascending or descending with the constant velocity, the weight of an object inside it is equal to the real weight. So a body will experience its real weight when the elevator is moving with the constant velocity. That is when the elevator is moving with constant velocity, the body inside it experiences its real weight. That is, apparent weight equals to real weight of the body when the elevator is moving with a constant velocity. Okay, case 4. When an elevator moving free with acceleration due to gravity G. Okay, here acceleration of an elevator is equal to acceleration due to gravity G. Acceleration A equals to G. Now, if we sketch the free body diagram, and this is weight mg and the apparent weight r. Now here acceleration of the body, acceleration of the lift is equal to g. Now from Newton's second law of motion, the net force acting on the body equals to mass times acceleration. So mg plus negative r equals to mass times acceleration. But here acceleration is equal to g. So mg minus r equals to mg. Mg and mg will cancel out, and when we rearrange the equation becomes r, apparent weight r equals to 0. Now, what can we say about this fact? When the lift is moving free, then the body inside it will experience weightlessness. The body inside it will experience weightlessness. That is, the weight of the body, the apparent weight, is equal to 0. Now, suppose if the elevator, case 5, suppose if the elevator descending with an acceleration A, and the acceleration of an elevator is greater than acceleration due to gravity. Now, what happens to the apparent weight of the body inside it? Don't miss the next lecture. Nice to meet you again.